Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode of our Strata Data Conference series, we're joined by Ashraf, data scientist at Pinterest. In our conversation, Ahsan and I discuss his presentation from the conference, Diversification in Recommender Systems, using topical variety to increase user satisfaction. We cover the various experiments his team ran to explore the impact of diversification in user boards, the methodology his team used to incorporate variety into the Pinterest recommendation system, the metrics they monitored throughout the process, and how they performed sensitivity and sanity testing. Before we move on, I'd like to send a huge shout out to our friends at Capital One and Cloudera for their continued support of the podcast and their sponsorship of this series. At the NIPS conference in Montreal in December, Capital One will be co-hosting a workshop focused on challenges and opportunities for AI in financial services and the impact of fairness, explainability, accuracy, and privacy. A call for papers is open now through October 25th. For more information or submissions, visit twimlai.com/C1NIPS. That's the letter C, the number 1, NIPS. Cloudera's modern platform for machine learning and analytics, optimized for the cloud, lets you build and deploy AI solutions at scale, efficiently and securely, anywhere you want. In addition, Cloudera Fast Forward Labs expert guidance helps you realize your AI future faster. To learn more, visit Cloudera's Machine Learning Resource Center at cloudera.com/ML. Now, if you're a fan of this show, you've got to love our sponsors because they help make it possible. So please take a look at what they're up to and be sure to let them know that TWiML sent you. And now, on to the show. I am here in New York City with Ahsan Ashraf. Ahsan is a data scientist with Pinterest. Ahsan, welcome to This Week in Machine Learning and AI.
Thanks, Sam.
So you gave a talk yesterday on the way you do recommendation systems at Pinterest. What was the specific title of the talk?
So the talk was called Diversification in Recommender Systems and how we can use content diversity to try and increase user satisfaction.
Awesome. Before we get into that, a little bit about your background. You have a PhD in physics. PhDs in physics are not unfamiliar to this podcast. There are a lot of physics PhDs in ML and AI. How did you get from physics to machine learning?
Yeah, so my background, as you said, is in physics. I used to study condensed matter physics and the physics of complex systems. So complex systems are often systems that are kind of hard to define using simple equations. And physicists, as you might know, really love to put an equation to everything. We like to say, hey, this is how the world works, and I can put that on a t-shirt. So complex systems are often systems that have a lot of interacting, a lot of moving parts, essentially. And I've always been interested in those kinds of systems. And a system like Pinterest is similar to that. Before that, I also studied a little bit in neural networks and worked in sort of soft matter physics, which is polymer physics, and any other materials that don't behave as we might expect.
And you also were an Insight Fellow. I know Ross and Emmanuel and some of the other folks that have gone through that program. Is that kind of how you made the transition into machine learning and AI?
Yeah, absolutely. So towards the end of my PhD, I started realizing that a lot of the work that I was doing was quite relevant to the stuff that people were doing out in the Bay Area, and it was a great way for me to be able to transition into data science.
Awesome. So what's your focus at Pinterest?
Yeah, so at Pinterest, we have a sort of small data science team. I work very closely with the ranking and blending team, and they essentially build what we call our main home feed. And so when you land at Pinterest, you kind of see a set of pins, and that feed is what we call the home feed. So what powers that feed is a set of interacting machine learning technologies. And one of our teams is responsible for kind of the ranking and the blending of a lot of that content. And I work really closely with those engineers.
Okay. And so the project that you described in your talk was on introducing diversification into that feed. What motivated you to start looking at that?
Yeah, so that's a great question. So machine learning systems often are a per pin system. Recommender systems try to say, I have this user and I have this item, and how likely is this user to engage with or to click on or to whatever whatever the system might be with this specific item. And the interesting thing is that they don't often, or at least naive or simple recommender systems don't often think about looking at things as a set of pins. Most recommender systems try to think of stuff as a per pin or a per item basis. But we obviously as human beings can feel that so the example that I gave in my talk was that personally, I love using Pinterest for street art. And, one of my favorite street artists is Banksy. And the recommender system can learn that I like Banksy. But what ends up happening is that rather than just giving me one Banksy pin, it ends up giving me 100 of them. Mm-hmm. And so recommender systems say, hey, if I know what this person likes, I'm going to give you 1,000 of these things. But obviously we have the notion of diminishing returns, right? So this is a pretty standard thing in economics where if you give me one of something, I might really like it, but by the 100th one, the additive value that you're giving me by showing me that piece of content is actually pretty low. And so that's kind of the primary motivation behind thinking about entropy or thinking about randomness and sort of content diversification within recommender systems.
Mm-hmm. And to maybe jump to the punchline a little bit, and I'll elaborate on why. Did you in fact find that diversification provided some additional lift or engagement?
Yeah, absolutely. So that's actually, I like to do that as well, where I try to give away the punchline right in the beginning. And so, yeah, the punchline is that diversity makes users happy, right? And the reason why is that Pinterest specifically is a visual search engine, right? Mm-hmm. People come into Pinterest to discover and do what the things that they love. And so they want to be introduced to a bunch of content mm-hmm. that they can explore and browse and then kind of dive deep into the things that they really enjoy. Mm-hmm. And sometimes the things that you really find, I mean, if you think about the last time someone recommended a good book to you or mm-hmm. A good art show to you, it often happens by chance. And the word for it is serendipity, right? And so what we want to do is we want to create serendipitous experiences mm-hmm. on Pinterest where people come on and they're able to find those things. And when there's more diversity, that is more likely to happen.
Right. So what prompted the question was, in fact, another interview that I had with a speaker at Strata from Reuters who looked at essentially recommendations. They were trying to determine the best articles to surface to a user in their infinite scroll redesign. So you go to an article, and when you're finished with that article, you see the next article automatically. And they looked at a couple of different experiments. One was surfacing similar articles, another was surfacing dissimilar articles, and the third was surfacing articles, just top world news articles. And they found that, in fact, in their case, similar articles had the greatest performance as opposed to dissimilar, which is kind of analogous to the diversification that you're describing. But I guess all this speaks to the fact that it's really about your users and the way they want to use your site.
Yeah, absolutely. I mean, that's a really interesting point. So the interesting thing about Reuters or any news or most news agencies, I should say, is that they're not personalized usually, right? Like Reuters is just trying
and they are not. Exactly.
So they're trying to give you content. Most of the content that they serve their users will probably be homogeneous. Mm-hmm. However, for us, if you look at a specific user's home feed, it's entirely personalized to that specific user, from the language that user speaks, to the type of content that they've engaged with in the past, to the users that they follow, to all these different things. And therefore, for us, diversification is actually a really important part of that. And I should also caveat that I don't think that, the extreme end of this, like if you could take it to the ad infinitum, it would be that everything should be random. And that's not what I'm saying either, right? There's some sweet spot. So in machine learning, we use the term explore versus exploit. And the idea is that if you really personalize, if you really say, hey, this user really likes Banksy street art, all I'm going to show this user is Banksy street art, that's like extreme exploitation. And extreme exploration is randomness. And there's some sweet spot between those two, which allows for this kind of discovery experience that we want to try and give our users.
And so how did you organize the presentation?
Yeah, basically, I start off by talking generally about the motivation, and then I sort of give a few examples of how do we actually measure this diversity. So one of the really important problems within, like in the past in literature as well as now, is we can intuitively feel that. Like I can tell you that this was a Banksy street art pin, but how do you actually give that information to a machine learning algorithm as a number or as something that could be an input to your system? And so I primarily focused, like more than half of my talk was trying to focus on how do we measure that and what are the kinds of tests that we can do to be able to understand that this measure is actually working for us. And so these things are things like, is my metric stable, which means that how, as I give it more information, does it actually kind of converge to a specific value? And how quickly does it converge? Because that's an important thing as well. Like I want to be able to give it, 10 pins or a few pins. Pins here are just our basic unit of content on Pinterest. And it should be able to give me a pretty good value. So that's stability. The second thing is...
You're giving it 10 pins and it's giving you a pretty good value of what?
Of diversity.
Okay.
Yeah, so you can imagine that with one image, so let's imagine we have 1,000 pins, right? There's some value of diversity that I can give that set of pins. And so you can, for example, if all those 1,000 pins were related to street art, the diversity of that would be pretty low because they're all street art. If they were entirely random, the diversity should be pretty high. So the number that I give it should be pretty high. Now, if I subsample, let's say, one pin from that 1,000 set of pins, maybe it's randomly happens to be not a street art pin, right? And then now I take 2 samples and now I can maybe get a better value of diversity. Now I take 3 and so on and so forth. And so how many pins do I need in order to be able to get to that number pretty quickly? This is what I mean by stability.
Okay.
And then the second important aspect of it is sensitivity, which means that does it behave the way we want it to behave? So the example here would be, again, like, let's say I have a set of pins and 100% of them are Banksy street art, right? And so the diversity value should be pretty low. Now let's say we start introducing a completely orthogonal topic into this set of pins. So imagine something like scooters or cars or whatever, something that we think is like different. And then we introduce some of these pins into this system, and we should see this diversity value kind of go up. When we're at 50-50, where we have 50% like scooters, 50% street art, then this diversity value should be at its max. And then as you keep introducing more and more scooters into it until we have 100% scooters, then this diversity value should come down again. And so if this measure doesn't move very much or it doesn't move the way we actually expect it to behave, then it's not working. And so this kind of a study of trying to understand if the measure is working is a sensitivity analysis. And so I talk a little bit about this.
One quick question on that. So you said that when you have this 50-50 distribution of pin topics, assuming we know how to find those, that this diversity measure should be at its max. That's a design decision, right? You could also argue that the diversity metric should be at its max when every pin is of a different topic. Totally,
yeah,
right?
Absolutely. Yeah. So what I mean by saying max is max in this in the spectrum of mixing these two topics. So you're absolutely right that if I introduced a third topic into this, now that value should be even higher than if I only have two topics.
Okay.
So that's actually another analysis that I didn't talk about in my talk, but we did do, which is that let's say I have 50-50 two topics, and now we have 30-30-30 three topics. And then let's say we keep going with like 25-25-25, like four topics and so on. We actually keep seeing that this value increases until some max point where it flattens out. And so that's also another aspect of sensitivity, which we also checked.
Okay.
But that's a great question.
Okay. And so the third.
Yeah, and so the last thing is basically in physics we just call this sanity checking, right? So we want to make sure that this metric is sensible for the system that we've now constructed. So on Pinterest we have something called boards. Boards are collections of pins or collections of these units of images that our users have kind of put together. And these are thematically often quite similar. So users create boards, for example, for flowers for their wedding, and so all of the pins on that board will be like purple flowers or something of that sort. People will create a board for scooters. I have a board, for example, for street art, and so on and so forth. And we generally know that these boards should be thematically quite consistent and quite similar. So one of the things that I did was I sampled lots of users' boards and tried to give those set of pins a value for diversity. And that creates a distribution. And this distribution now should be lower than lower in diversity from the distribution if I just randomly sample pins from our corpus, from our system. And so we basically created multiple distributions like this just to make sure that the distribution for boards is actually like the mean and everything is much lower than the distribution for random pins. And then the distribution for sessions, or when users come on, what do they see on Pinterest, is actually kind of overlapping between those two things, because sometimes users come on to see pretty random content, but sometimes users may come on just to see something very specific. And so we see that the sessions, not only is the mean kind of that distribution making sense, but the standard deviation is a lot bigger too. And so we know that it's more spread out. Okay. And that generally kind of makes sense as well. And so given those three checks of stability, sensitivity, and sanity, we can then become quite confident that this measure is something that we can use.
Were you able to look for boards that were titled miscellaneous or random and compare them in diversity to other types of boards?
Yeah, that's a good question. I tried doing some stuff where I looked at specific topics and saw that within boards, topics of boards of one topic can be different in diversity than boards of a different topic.
Okay.
I think the most
meaning consistently.
Yeah, exactly. Or in general, like if you create those distributions, they often are non-overlapping, one being greater than the other. I can't remember right now what a specific example, but like one of the things I think was that crockpot recipes was much lower in diversity than a board titled like wedding or a board titled something like that. And I guess the thing is that wedding is a much broader category. Like you could have anything from dresses to flowers to all sorts of stuff in wedding. Whereas if you have crockpot recipes, they're quite specific, I guess. And so things like that we definitely saw. But that's a good point about boards being titled random and if they were in fact random or not.
Yeah. You may be coming to this, but I'm curious how you got at what the pin's content was. Were you looking at metadata? Are we doing deep learning on the images?
Yeah, so that's a great question. So when users put a pin onto our system, they generally put it on a specific board, which has a title and a description and stuff. And then the pin itself has a description too, where users can write some stuff about the image that they've uploaded. And then often pins actually have web pages associated with the content, right? And so when you try to, when we have all this information about the pin, we can actually associate certain words with these pins. And so The example that I gave was if you have a street art pin, the words that are associated with this are things like art and, graffiti or Banksy and so on and so forth. And we call these words associated with pins pin annotations.
Okay.
And so that's kind of step one, which is that try to get to the key topics of the pin. And we do this by this kind of tokenization of these words that we can get from the descriptions, the board titles, the web pages, so on and so forth. Once we have these annotations, we can actually use, in my talk, I walked through several measures of diversity that you can use. One of the problems with words, though, is that they're synonyms. And so when you say like art versus street art versus graffiti or something of that sort, these have overlapping meanings. And because of that, we actually couldn't get very stable measures of diversity using purely words, using purely annotations. So there's a lot of work on lexical diversity in linguistics literature. And then, so you can use some of those standard techniques. We also tried using some techniques like entropy or the Gini coefficient, which are from like physics or economics. And then, but at the core of it, the issue is that annotations or words can often have synonyms, and there's the inherent instability in that. And so what we ended up doing was creating these embeddings using matrix factorization. And so what embeddings try to do is that they try to map these words onto vectors, right? And not just any vectors, but some quite special vectors in the sense that you can add and subtract these vectors and they still have meaning. So the very standard example that people give is that if you have the vector for king, you can subtract man and add a woman and then get queen out of that. And the fact that works actually still blows my mind, because it's quite incredible that we can do that in such a way that we can still interpret and makes a lot of sense. And so we actually do exactly that, where we take these annotations and we know that annotations on a specific board are related to each other. And so we use that matrix of annotations as columns and boards as rows and factorize that to be able to get annotation embeddings. And so once we have these annotation embeddings and we know that each pin has associated, like, let's say we take the top 10 annotations for each pin. Now, because of the fact that these embeddings can be added and subtracted and stuff, we can actually just take the average of it, and that average still has meaning. And that embedding we call the pin embedding. Okay. And so once we have that pin embedding, now we can actually do simple things like, calculate the similarity or dissimilarity in this case of different pins, and be able to give that kind of get that embedding diversity value out of that.
Is there a single pin embedding at Pinterest, or do you have multiple different types of pin embeddings that you use? Like, is that a pin annotation embedding, and there are other types of pin embeddings?
Yeah, that's a great question. I mean, we definitely have a lot of embeddings, and we're trying to converge to a single unified embedding which encapsulates everything. And so a lot of the stuff that I've talked about so far has been about the words that are on the pin, but you can imagine that there's a visual embedding, right? An embedding that's purely based on the image itself. And we definitely have a team that entirely focuses on trying to create a visual embedding. And we actually recently launched something which tries to combine the two. And there's a podcast, there's a blog post about that I can link at some point.
So you talk through the properties of the metric, and then you're using embeddings to develop the metric. What else did you talk about, or what was next in your talk?
I mean, so the final step obviously is that we have the problem. We've kind of motivated it.
Right.
We have sort of the solution, which is how do we measure the diversity? But then the final step is how do we actually implement this into our system? How do we use it, right?
And actually, before you jump into that, you mentioned a couple of alternatives, some lexical work from the linguistic space and entropy and things from physics. How far did you go down those paths? Or did you kind of look down those paths and say, hey, we don't want to go down there?
Well, we definitely we went far enough where we were able to understand what the pros and cons of those approaches are and whether it works for us. And when we found that something doesn't work for us, we kind of moved on from there. And so the very first example, there's something called the type token ratio, which just takes the unique number of annotations and divides it with the total. And so this is something that's like very easy to understand. And that's, I think that is the pro of some of these approaches, which is that, interpretability is a really important aspect in machine learning, which people sometimes ignore these days. But that does have its value and merits. And so I think the point just being that like you kind of have to try it out, see what the pros and cons are, see if it matches the three conditions that I mentioned of like stability, sensitivity, and sanity. And if it doesn't, then you kind of move on to the next approach and stop where you find something that works.
So this type token, for example, pretty simple, but it really trips up with the synonyms.
Exactly, yeah. And so you can imagine that if I have some two pins that are quite different, but then might have overlapping annotations, it just won't understand. Or if they're quite similar, like imagine slow cooker and crockpot, which are two separate words, but have quite the same meaning. It'll actually think that they're very different, and so it just doesn't behave the way that we want it to behave.
Right. So the implementation of the system, what were some of the big challenges there?
Yeah, so before jumping into the implementation, I'll just quickly describe what our recommendation stack looks like.
Okay.
And so we start off with, our pin corpus, which is sort of billions and billions of pins. We narrow that down to a stage called candidate generation, where we have a bunch of different ways of generating candidates for recommendations. And so some of these involve purely content to content type recommendations, but some of them involve more like collaborative filtering type approaches, and so on and so forth. Like we have a lot of these different approaches. And at this stage, we kind of get about off the order of thousands of pins for our users. The next step is pure ranking. So
meaning for a given user's home feed, you'll get thousands of candidate pins?
Exactly.
Okay.
So when a user comes onto Pinterest, we're doing all of this stuff in the background before they even land on the home feed. So the next step is ranking, where we just blend all of or put all of these things together and try to say, well, how do they actually perform against each other? What is the probability that this user will in fact engage with this specific pin or not? And then the final step is actually blending. And at this stage, we're taking content from the user's followers, from the user's from the user that the viewer follows, from the topics that they're interested in, and finally from their recommendations, which are these machine learning systems. And we're putting them all together into a single feed, or creating a chunk, as we call it. And so at this final step, you can imagine that there's a lot more control in trying to tune this explore-exploit balance of, do we want to try and show users 100% things that we know that they will engage with, or do we want to sneak in some more exploratory stuff? And so this is the stage at where we started adding this diversification. And the way that we essentially did it was that we would calculate this embedding dissimilarity metric for all the pins that we were about to show the user. And we said, is it too similar? Is it the first few pins that this user is going to see? Are they all very, very similar? And if they are, then we push some of the pins down and we actually introduce more sort of randomness and more entropy into the system.
And do you consider this at all a personalization parameter? Like user A wants more diversification in their field than user B?
Yeah, that's a great question. So we are also trying other approaches of introducing diversity. And so one of the ways of doing that is actually adding it into to our ranking function, essentially. And these things are often called submodular functions. And so there is an approach of doing something like that as well. We specifically found that this approach of just kind of looking at the final product and then seeing if it's too similar and just penalizing at that step works slightly better than actually trying to do it the other way. That's not to say that it won't work for anyone else. I think it's just a matter of the system and how it behaves. But that's definitely one of the options as well.
So the pin embeddings, did that pre-exist this particular project? Was it already available for you, or did you have to create that as part of building out this system?
So we actually had to create new pin embeddings for this. And the reason why often is, again, the characteristics of the embeddings that you want can often differ from different use cases, from use case to use case. And so the given pin embedding, the embeddings that we already had just didn't behave the way that we wanted them to behave. And this is again the thing of for a lot of these systems. The technologies are often already out there. Mm-hmm. You kind of just have to pick and choose like what works for me and what is the problem that I'm really trying to solve. And at the end of the day, it is great to try and build out something new, but at the same time, if something already works, you just use that. And in this case, we just realized that we had to create something new to be able to solve this problem.
Mm-hmm. So you haven't talked much about kind of the operating characteristics, scalability requirements. I mean, clearly you talked about how many pins there are and the number of candidates. Did the solution the direction you started going, did it just kind of work fine? Or did it have to be massaged in order to get it to perform to meet the requirements of the site?
Yeah, that's actually a great question. So when we think about the pros and cons between, let's say, like the annotation diversity that I talked about and the embedding diversity, that was actually a big thing that we took into account when deciding on which approach to choose. And so the reason why, and so in this case, embedding diversity actually it is better in terms of scalability. And the reason why is because embeddings are numbers, and numbers are easier to, store and add and subtract and do all these things to, instead of actual words, which are the annotations. So if each pin has, hundreds of annotations associated with it, and we're trying to find what's the overlap between two things, you literally have to go through every single one and kind of, see which ones overlap. And that's actually a very expensive process if you want to do it at scale. And so for embeddings, which are just vectors, we can actually add and subtract them fairly easily. And there's libraries that do matrix factorization and stuff like that pretty fairly. Having said that, matrix factorization is actually something that's very hard to do at scale. And in that case, what comes into play is sampling, but sampling in the correct way, in the sense of like sampling in a way that doesn't introduce biases into your system. And that in itself is a topic that's really hard to do. We ended up using reservoir sampling, but there's...
Can you elaborate on this whole area? What are you using sampling in place of creating embeddings for every pin? Is that what you're suggesting?
No. So I guess if you come back to the matrix that we're factorizing, we're essentially looking at annotations as the columns and the rows being boards here. And so the reason why we're using boards is because we think boards are more thematically similar. And if we do it on boards, we're able to actually get at the meaning of that annotation a little bit better, or the vector that we're going to associate with this annotation a little bit better. And so the sampling that I'm talking about is actually at that board level, which is that how many boards do we sample? What are the topics that we sample these boards from? And you can imagine that if I just do it randomly, I might create biases for things that people create a lot of boards for versus things that people don't create a lot of boards for. And so we have to be quite smart about that when we're trying to do this.
Makes sense. And how did you approach that?
Yeah, so I mean, obviously we started simple. We started with the trying to do it the very simple way, where we just did a random sample, recognize what is the granularity at which we want to be able to find differences between these boards, and then try to skew it in the opposite way of that. So if we have a lot of boards from a specific piece of content, we try to sample less from there, and then we oversample places where we don't have enough content.
If you have a lot of boards meaning a lot of boards that a specific piece of content belongs to?
A lot of boards that are thematically quite similar. And so the idea here is that, let's say, we have a lot of users creating wedding boards. And so it could be that if I just sample randomly, I end up getting just a lot of wedding boards. But we also want to make sure that we have boards for scooters, or boards for street art and all this other stuff. And if there's not enough boards that are just being created for that type of content, we actually have to oversample there and undersample boards that are being created just in volume a lot more.
Would it be a reasonable approach to look at creating an embedding space for boards and then using that embedding space for boards to try to determine diverse boards and then using that to feed into your pin embedding?
Yeah, I mean, so at Pinterest, we are actually quite lucky where we have this really nice graph of, a user creating a board and that board having a bunch of pins on it. And then often these pins overlap with other boards. The most smallest unit in this obviously is the pin. And so we can roll up to the boards if we want. But you're right in the sense that we could do it at the board level and then roll it up to the user or something of that sort. But given that we have the pin embeddings, we can actually just roll it up to the user, roll it up to the board, and then be able to get that value for the board as well. And so it's often good to be able to start at the most basic unit and kind of roll it up if needed, because then you have the granularity, right?
Yeah, I guess that makes sense. Totally makes sense. And so implementation.
Yeah. So as I said, at the blending level, we're able to kind of tune this explore exploit balance. And the idea here simply is that we take the set of pins and what we do what's basically known as first page optimization. And so the idea is that one of the things that we'd found with these embeddings is that the top of users' feeds are often the least diverse, in the sense that recommender systems often try to shove everything that they think that the user will really engage with right at the top of the feed, which kind of makes sense because, again, recommender systems are trying to do this at a per item or a per pin basis. They're not really thinking too much about, like, what does the page look like? How does this pin look like in association with the pins that it's surrounded by? And so that's the reason why, this is actually quite effective at that Blender level, because now we have a set of pins. Now we have this page that before we show the user, we can kind of take a look at and be like, hey, does this kind of look good together? And so the lower diversity at the top of the feed actually often makes users feel that, this is all the stuff that I'm going to see. But if you actually scroll a little bit lower, there is a lot of content that's more diverse. We're just not showing it right at the top. And so if you actually push some of that content further up the feed, you can kind of, users are able to be exposed to more diversity right at the top, which kind of encourages them to explore more.
And so when you talk about this, the focus being this first page diversity, does that mean that after the first page of recommendations, you're not going through the same process and assuming that the recommender is already going to produce a more diverse feed?
So we do go through the process even after the first page, but it becomes more crucial right at the top,
right? Because
that's where the issue that we found was. We also found that the issue was actually more severe in users that are the most active. So the more active that you are, the more we know about you and the more we're able to kind of over-optimize on the interests that we know you have as opposed to the interests that you may or may not have, right? And so there's a bunch of things here that the quantitative measure of diversity allowed us to do. And so the first thing, as I mentioned, is the fact that we understood and recognized that the problem was more severe at the top of the feed versus lower down. The problem was more severe, for example, for users that was the most active. And then we can also do things like try to understand, well, is this problem more severe for users that speak a different language, or users that so there's a lot of other properties of this that we can now kind of understand a little bit more and tackle those problems head on, as opposed to just kind of thinking about diversity as a more qualitative problem. We can try to focus on specific quantitative approaches of doing that.
All of this is based on understanding what engagement means for these pins, and there are kind of the obvious things like likes, thumbs ups, those kinds of things, comments. But when thinking about the board and diversity on the board, a lot of times it's just, what you see when the board comes up, and that having making a qualitative impression on the user. Did you do user studies or things like that outside of just kind of the pure click engagement metrics?
Yeah, absolutely. So this issue actually was, so we have an entire team that's devoted to try and talk to users, do a lot of qualitative research to be able to understand what are the problems that users are facing. And then we obviously listen to a lot of the comments and stuff that users give us as well. And so this problem actually we studied quite in depth, where we got a bunch of users to come in from varying backgrounds, and we tried to understand what are the problems that you're facing, and so in my talk, I actually give a few quotes from some of our users that specifically talk about this problem, where users say, well, I see the same stuff all the time, or I want more diversity, and I want more new content or new topics. And, I want Pinterest to kind of broaden the types of things that it shows me and stuff like that. And so we kind of approach it from a bunch of different ways. Like we have very in-depth studies where we sit down and talk to users for an hour. We have, a way for users to write to us and do all sorts of stuff like that. And then we have user surveys, which are sort of quick responses. And then finally, we have the experiments that we run where we try something out. And in this case, we tried this specific approach that I described out in an actual experiment. And then we try to see, do users come back more often? And two, when they do come back, do they spend more time, and do they actually feel like they're engaging more? And so we saw a lot of these approaches kind of converging on the same thing, which kind of tells us that we're doing something right.
So another way to come at that is that for this type of problem, you're optimizing more on site engagement than pin engagement per se. Is that fair?
Yeah, I think that's fair. I think often those two things correlate, where site engagement often correlates with how often people engage more with content. But users come on for a bunch of various reasons. So and users have different ways of engaging. So some users may come in and click a lot, or what we call repinning, which is that they take pins that they see and put them on their own boards. But then some users just come on to explore, right? Users are coming on to design things and actually take actions on those things. But they're also just coming to, for entertainment. They just want to see a bunch of content. They want to try and explore new ideas or explore new aspects of themselves. And we don't want to over optimize on one specific type of user base. We want to try and do it more holistically. And site engagement is a good proxy for that.
So you've inserted this into your pipeline. You've got it up and running on the site. You've done some experiments. We know that you found that increased diversity worked, but how exactly did you measure that?
Yeah, so finally we did an experiment. We actually did a series of experiments, and the final one that we decided to launch was one where, as I mentioned, users are coming back more often to the site. And so that's one of that basically tells us inherently that users did find value when they came once, and therefore they've decided to come back. And that's a really important measure for us. And then the second thing is, when they do come on, do they engage more? Do they repin more? Do they spend more time? And so we actually saw that we increased time spent by about 1%, which is quite huge. And then we were also able to increase the number of pin impressions that users were seeing. So that just meant that every time they came in, they actually scrolled deeper and had longer and hopefully more meaningful sessions. And that was finally our sort of proxy for saying that this is something that's actually providing value to users.
But to kind of start to wrap up, what were the key takeaways that you left the audience with?
Yeah, so sort of the main thing that I think that this shows is that measuring content diversity or measuring diversity in any recommender system is incredibly important. And the reason why it's important is because it's not just a tack on that you can put right at the end of your system. It's actually something that's inherently fixing a pretty common flaw that recommender systems have, which is that recommendations are often per pin or per item. And they're not taking into account things like, diminishing returns or how do people look at something when they see lots of stuff at the same page, which is how we as human beings actually interact with the content. We don't see things like, hey, look at this one thing and then look at this one thing and so on and so forth. We actually often see things in a holistic view. So it's incredibly important. It's non-trivial in the sense that you can't just use the first thing that comes to mind. You often have to do a lot of analysis and a lot of kind of deep studies in terms of, stability, sensitivity, and things like that to be able to understand, is this measure right for the system that I'm working with? And then finally, it's important, it's non-trivial. And then when it's actually done well, it can have a lot of real user impact. It can make your users much happier. And this is something that we finally showed through these experiments and this implementation that we had. But the final takeaway just is that measuring diversity in recommender systems is actually important, non-trivial, and can have real user impact.
Awesome. Well, Ahsan, thank you so much for taking the time to share this with us.
Yeah, thank you so much, Sam.
All right, everyone, that's our show for today. For more information on Ahsan or any of the topics covered in this show, visit TWiMLAI.com/talk/187. For more information on the entire Strata Data podcast series, visit TWiMLAI.com/StrataNY2018. Thanks again to our sponsors, Capital One and Cloudera, for their sponsorship of this series. As always, thanks so much for listening, and catch you next time.